Now, question 6. It says, at a track meet, a cylindrical container fitted with a pipe as shown in the diagram below is used to serve water to athletes. The cylindrical container of radius 12 centimeter and a height of 20 centimeter is completely filled with water, and the pipe fitted at the bottom dispenses water into cone-shaped cups. The cone-shaped cups have a radius of 3 centimeter and a height of 8 centimeter. Calculate the volume of water in the cylindrical container in liters, and then write your answer correct to 2 decimal place. So first thing they're asking us to do is just work out the volume of the cylindrical container. The cylindrical container is what was given at the start, a cylindrical container. This is the cylindrical container. Now, volume of a container, the volume of the container, always remember it's equal to area of the cross-section multiplied by the height. That's how we find volume. Volume is area of the cross-section times the height. The cross-section in this case is a circle. So doing this question now, we can tell him that the volume would be equal to area of the cross-section. This is the cross-section, this circle right here. The circle is pi r square h. Pi times what is the radius? The radius is 12. That's 12 square times the height of 20 centimeter. And so the volume works out to be, we put that in our calculator, so I'm going to take it out. The calculator is giving us pi multiplied by 12 square multiplied by 20. So the calculator shall give us 280 pi, but I want the exact number. The exact number is 9,047 point, let me see, 9,047.79. And that's in centimeters cube. The volume that we found was in centimeter cube, but they said give your answer in liters. So since 1,000 centimeter cube is 1 liter, we're going to have to divide this by 1,000. Dividing it by 1,000 going to give us that the volume is equal to 9,000 divided by 1,000, leave 9. So it's going to be 9 points. Bring over the decimal 3 places. 1, 2, 3. That's 9.05 liters. All right, that's the volume. We have to divide it by 1,000 because 1 centimeter cube is equal to 1 liter. So you have to divide it by 1,000. All right. Now part B, it says, water flows from the cylindrical container along the pipe into the cone-shaped cup at a rate of 7.8 ml. ml should be milliliters per second. Calculate the time taken to fill one of the empty cone-shaped cups. Give your answer correct to the nearest second. How long it's going to take to fill one empty cup? So first, we need to work out the volume of one of these cups. One of these cone-shaped cups. Now, what's the volume of this cone? They told us that the volume of the cone is 1/3 pi r squared h. So good. They gave us the formula, so we don't have to do much calculation. It's going to be volume is equal to 1/3 times pi times r squared. The radius was, looking back at the question, what was the radius? Let me scroll down so we can see it. The radius was 3 centimeter. The radius of the cone is 3 and the height is 8. So this is 1/3 times pi times 3 squared times h, which is 8. This is the volume of the cone. So the volume of that small cone let me put VC, meaning volume of the cone. So the volume of the cone is equal to, put that into your calculator. Put it into our calculator, it's going to be 1/3 multiplied by pi, multiplied by, I know that 3 squared is 9 pi, but I want the decimal equivalent. The decimal equivalent is 75.4, and this is in centimeters cube. So if we divide this by 1,000 to get it into liters, we need to divide it by 1,000. Dividing this by 1,000 is going to give us, it's equal to now 0.0, this is 0.075 liters, 0.075 liters. But this is equivalent to 7.5 milliliter. If we transpose it to make it milliliter, this is 7.5 milliliter. So the volume of the cone is 7.5 milliliter. But here's the thing now. It says water flows in the container along the pipe at a rate of 7.8 milliliter per second. So if 7.8 milliliter corresponds to 1 second, right? That's 1 second. Then what we then know is 7.5 milliliter is going to go to X. So to work out how much time it's going to take to fill that small container, that is going to be, we know to do this now. We cross multiply. So cross multiplying, that will end up give us that X is going to be 7.5 divided by 7.8. And 7.5 divided by 7.8, we'll put that into our calculator. That is roughly 0.96. So it takes 0.96 seconds. 0.96 seconds. But the question said, give your answer to the nearest second. So to the nearest second, this is your answer. Your answer is equal to 1 second. That's your answer, 1 second. It's just going to take 1 second. So in the space of 1 second, the container will be filled. Easy question. In the space of 1 second. Wow! All right, now in part C, it says determine the number of empty cone-shaped cups in B that can be completely filled by the cylindrical container. So we need to determine how many of these cups can this container fill. Now, first thing is we know the volume of the container. Look at this. So the number of cups, let's call it N, is just going to be the volume of the big container divided by the volume of the cone. The volume of the container we found was 9.05 liters. I was positive that's what we got, 9.05. Volume is 9.05, yes. So the volume of 9.05 liters, we're going to divide it by the volume of the cone. The volume of the cone in liters was what? Volume of the cone in liters was 0.075 liters. Whoa. Wow. The volume of the cone is 0.075 liters. So dividing it by 0.075 liters. So when you put that into your calculator, what you're going to get is, do the division, 9.05 over 0.075, that will give us 120.66. 120.66, but it says how many will be completely filled. Completely filled will be 120. All right, so 120 will be completely filled. That's it. So notice we leave off the 120.666. We'll leave off the 0.666 because that wouldn't be completely filled. 0.666 is like, imagine you have 120 completely filled, 120 of them being completely filled, and then one container being 2/3 filled. That's not completely filled. So it's just the 120 that was completely filled we'll focus on. So 120 is the answer. All right, 120 will be completely filled.